classes. In this class, I will teach you chemistry. First chapter, some basic concepts of chemistry. Some basic concepts of chemistry. First, what is chemistry? Chemistry is the branch of science which studies the preparation, properties, structure, and reactions of matter. Second, the basic constituents of matter are atoms and molecules. Atoms and molecules. So, chemistry is called science of atoms and molecules. Chemistry plays very important role in our daily life, and some of its most important applications which are used in our daily lives, like there are so many applications where we used there are so many things in which we use the application or applications in which we use chemistry, like functioning of brain, operation of computer. If we want to making the weather pattern, then we use the principles of chemistry. And if you want to production in chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, etc., including so many new materials in which we use the chemistry. And chemistry also helps in the synthesis of many life-saving drugs, like cisplatin and Taxol. Taxol is also used in cancer therapy. It is very effective in cancer therapy. And AZT, which is effective for AIDS. And third one, uh, chemistry is better understanding of chemical principles, properties which leads to production of optical fibers, conducting polymers, and several advances in automotives, aerospace engineering, which rely on improved materials like ceramics, which are synthesized and engineered in chemistry, safer alternatives to environmentally hazardous substances like CFC, chlorofluorocarbons, which are responsible for ozone layer depletion, and they have been successfully synthesized. Next, what is the nature of second topic is nature of matter. Matter is anything that has mass and occupies space, like book, pen, pencil, etc. Means matter is anything which has mass, volume, and which occupies space, that is known as matter, like book, pen, pencil, etc. And what are the states of matter? There are three types of states: solid, liquids, gases. Solid states, they have definite shape and definite volume, ice, pencil, wood, etc. And liquid, they have definite volume but not a definite shape. So they usually take shape of container, like water and milk, etc. Gases, they have no definite shape or volume and they completely occupy their space in the container in which they are placed, like water, vapor, air, etc. Now next topic is the two other states, like plasma and Bose, instant condensate is known as and these forms exist only in the extreme condition of temperature and pressure. These are present for only in the condition of temperature and pressure. You can say there are two other states, plasma and Bose. Bose instant in instant Bose instant condensate is also known, and these forms exist only in extreme conditions of temperature and pressure. And three states of matter are interconvertible under different conditions of temperature and pressure, like solid. Solid converted into liquid after melting, after heating, and liquid converted into evaporation, liquid converted after evaporation or heat in gas form, or in another way you can say after cooling, after condensation, gas convert into liquid and liquid convert into freezing in cool, and it convert again solid form. It means when we convert solid to liquid, liquid to gas, this is a sublimation, and when we convert gas to solid form, this is known as deposition. Now next is a difference between solid, liquid and gases. First difference is particles, arrangements of particles. In solid, particles are held very close to each other in an ordered manner. But in liquids, particles are close to each other but not so ordered or as solids. In gases, particles are far as part apart as compared to that of solids and liquids. Second, movements of particles. In this, particles are not free to move, but in liquids they can move around, and in gases movements of particles is easy and fast. Third one, compressibility and hardness. In solid, hard and incompressible due to the close packed structure, and liquids more compressible due to more empty space. Gas is most compressible due to large inter particle empty space. Volume. In solid, definite volume. In liquid, definite volume, but in gases not definite. Shape. In solids, definite shape. In liquids, not definite, takes the shape of a container in which they are kept. And gases, not definite, completely occupy container in which they are placed. Diffusion. Solids, they do not diffuse. Liquids, they show slow diffusion, and gases, they show the fast diffusion. Now next topic related to classification of matter. Matter have mass and occupy space. Matter are two types: pure substances, mixture. And pure substances have fixed composition. There are two types of composition: elements and compounds. And in elements contain only one type of particles, that can be atoms and molecules. And in compounds contain more than one type of particles but in fixed ratio. Mixture have variable composition. There are two types of composition, variable composition. There are two types of mixture: homogeneous, heterogeneous. Homogeneous mixture means uniform composition throughout: salt and sugar solution, air, etc. Heterogeneous mixture means non-uniform composition throughout, like example alloy and colloids, etc. Pure substances means they have fixed composition and their constituent particles, and they cannot be separated by physical methods like gold, silver, water, glucose, etc. And pure substances, they can further classified into elements or compound. An element is defined as a pure substance which contain only one kind of particle and which may an atom or molecule like sodium, copper, silver, gold, aluminium, etc. And depending upon the physical and chemical properties, elements are classified as a metals and non-metals, etc. Compound is a molecule of a compound which is formed by the combination of two or more atoms of different types of different elements in a fixed ratio by mass. Example, water, ammonia, carbon dioxide, gypsum, sugar, etc. The properties of a compound which are different from those of its constituent elements. Example, H2O2, these are the gases, and whereas compound formed by their combination, it makes a water, that is a liquid. And second is a mixture. There are two or more substances when mixed together in any ratio to make a mixture like air, milk, tea, etc. Pure substances making mixtures, they are called its components. Components of a mixture, they can be separated by using physical methods. Mixture can be further divided in two parts: homogeneous mixture, heterogeneous mixture. Homogeneous mixture means that the particles of components of mixture are uniformly distributed throughout the bulk of mixture, and they cannot be seen separately, and its composition is uniform throughout. Example, salt solution, etc. Heterogeneous mixture, the particles of components of mixture are not uniformly distributed throughout the bulk of mixture, and they different components, they can be visible. Example, mixture of salt and sugar, gunpowder, smoke, etc. Now next topic is related to properties of matter and their measurements. Next topic is properties of matter and their measurements. Each substance each substance is associated with some unique set of characteristics, unique set of features, which are collectively called as properties of matter. First property is physical, second property chemical. Now first physical property means those properties which can be measured or observed without changing the identity or composition of substance, and these are called physical properties like color, odor, melting point, boiling point, density, etc. These are the physical properties. Chemical property means those properties which require chemical change to occur for their measurement or their observations. They are known as chemical properties, like characteristics reaction of different substances like acidity, basicity, combustibility, etc. Now next point is unit of measurement. Unit of measurement. Unit of measurement means many properties of matter like length, area, volume, etc. Like length, area, volume, etc. They are quantitative in nature, and they are called physical quantities, and these quantities are measured by the help of units. And a unit is defined as the standard of reference. Unit is defined as the standard of reference chosen to measure a physical quantity, and each and every physical quantity is represented by number of followed by units in which it is measured. For example, if we want to find if we say that the length of a pen is 10 centimeter. So here 10 is a number, and centimeter denotes cm, that 10 centimeter. 10 is a number and cm is a unit. Cm is denotes centimeter, which is the unit in which length is measured. And there are two different system of measurement, like English system, metric system, and nowadays standard in standards system is widely accepted. Now international systems of unit. SI unit means International System of Units. This system was established by 11th General Conference on Weights and Measurements, and the SI units, SI systems has 7 base units. 7 base units, and these are called fundamental units, and which are independent and cannot be derived from any other units. They are independent, they cannot be derived from any other units, and these units along with their symbols are shown in a table. You can see these are the base physical quantities and their units. First is a length. Length represent by L in a symbol for quantity, and name of SI unit is meter, and symbol for SI unit is small m. Mass symbol for quantity small m, and name of SI unit kilogram, and in symbol for SI unit is kg. Time small t, second, and small s. Electric current capital I. Name of SI unit ampere, and symbol for SI unit capital A. Thermodynamic temperature capital T. Name of SI unit Kelvin, symbol for SI unit capital K. Amount of substance small n, mole, and mol, symbol for SI unit. Luminous intensity IV, candela, and CD is symbol for SI units. Now listen carefully. Unit of length, that is meter, and it is defined by taking a fixed numerical value of speed of light in vacuum, and it to be 299792458 when expressed in the unit, and when expressed in the unit m s raised to power minus 1, and the second here is defined in the terms of cesium frequency, that is delta VCS. Next, unit of mass kilogram. It is defined by taking fixed numerical value of Planck constant h to be 6.62607015 multiply 10 raised to power minus 34, and when expressed in the unit JS or kgm raised to power 2 s raised to power minus 1. Unit of time second, it is defined by taking fixed numerical value of BCS, the unperturbed ground state hyperfine transitions frequency of 133 atom to be 9192631770 when expressed in the unit Hz has Hertz Hz, and which is equal to S raised to power minus 1. Unit of electric current ampere. It is defined by taking fixed numerical value of elementary charge E to be 1.6021766634 multiply 10 raised to power minus 19 when expressed in the unit C, and that will be equal to AS. And second is defined in the terms of delta VCS. Unit of thermodynamic temperature, that is Kelvin, and it is defined by taking fixed numerical value of Boltzmann constant K to be 1.380649 multiply 10 raised to power minus 3. When expressed in the unit, it will be Jk raised to power minus 1 or Kg m square S raised to power minus 2 and K raised to power minus 1. Unit of amount of substance mole. It also represent by mole raised to power minus 1, and it is also known as Avogadro number. Unit of luminous intensity candela, and it is represented by it will be represented by Kg raised to power minus 1, m raised to power minus 2, s raised to power 3, etc. Now I am going to discuss some prefixed used in SI system. These are the prefixed used in SI system. 10 raised to power minus 1, 10 raised to power minus 2, 10 raised to power minus 3, 10 raised to power minus 6, 10 raised to power minus 9, 10 raised to power minus 12, 10 raised to power minus 15, 10 raised to power minus 18, 10 raised to power minus 21, 10 raised to power minus 24. First 3, 1, 2, 3, after that plus 3 plus 3 plus 3, and in power. And first 10 raised to power minus 1 is a deci, and DECI, and 10 raised to power minus 2 centi, and 10 raised to power minus 3 milli, 10 raised to power minus 6 micro, 10 raised to power minus 9 represent to nano, 10 raised to power minus 12 represent to pico, 10 raised to power minus 15 from femto, and 10 raised to power minus 18 auto, and 10 raised to power minus 21 Japto, 10 raised to power minus 24 Yocto. And symbols D, C, M, mu, N, P, F, small a, small z, small y. And multiple 10 raised to power 1, 2, 3, 6, 9, 12, 15, 18, 24. And prefix deca, hecto, kilo, mega, giga, tera, peta, exa, zeta, iota. And symbol will be DA, small h, small k, capital M, capital G, capital T, capital P, capital E, capital Z, capital Y are used. Now next, some physical quantities. Some major physical quantities which are given below. First is the mass and weight. And mass is the amount of matter which present in a substance, and it remains constant for a substance at all places. And its SI unit is used kilogram, and 1 kg that should be equal to 1000 gram, and which is used. Analytical balance or electrical balance is used to measure the mass of a substance. Weight will be force which exerted by the gravity on an object, and it varies from place to place and due to the change in the gravity. and its unit is Newton, and capital N, and W is equal to mass multiply gravity. This is very important formula for weight, mass into gravity. What is the volume? Volume, the space which occupied by matter is called a volume, and volume is equal to length raised to power 3 and is equal to m square power 3. SI unit of volume is m raised to power 3, and in laboratory smaller volume like centimeter cube power cube, uh, cube centimeter, m or ml milliliter or dm cube or l liter are used. A common unit liter is used for the measurement of volume of liquid. L is not SI unit. These terms are correlated as 1 liter is equal to 1000 milliliter, and 1000 milliliter is equal to 1000 centimeter power 1000 centimeter power cube, and is equal to 1 cube decameter. 1 cube meter is equal to 10 raised to power 6 centimeter cube, and that should be equal to 10 raised to power 3 decameter cube, and 10 raised to power 3 L. Now next, first example is given in which you have to convert in given value, convert into basic units. You have given first value that is equal to 28.7 pm. 28.7 pm can be converted by multiplying 10 raised to power minus 12 small m over 1 pm. You can pm means picometer. This is pico, and 1 pico is equal to 10 raised to power minus 12 m. Now when we solve it, it will be equal to 2.87 multiply 10 raised to power minus 11 meter, and the next value is 15.15 mu s, and here mu represent to micro, and it will be equal to 10 raised to power minus 6 over 1 mu s, and when we solve 1.515 multiply 10 raised to power minus 5 s, and next value is given to 25,365 mg, and m small m is represent to milli. Milli is equal to 10 raised to power minus 3. You can see in a table 10 raised to power minus 3 g over 1 mg, and after solving it 2.5365, and it also multiply by 1 kg over 1000 gram, and it will be equal to 2.5365 multiply 10 raised to power minus 2 kg. Now next topic is density. Density is equal to mass over volume. How to calculate density? Mass over volume, and its unit will be kg meter raised to power minus 3, or g centimeter power minus 3. Density of substance tells about how closely its particles are packed. Now next example, a liquid has a volume. Volume is given, that is 49.0 centimeter power 3, and mass is given 57.642 g, and we have to find out density in a density of this liquid in a SI unit. Density is equal to mass over volume, 57.642 over 49.0. This is gram and this is in centimeter power 3. Now first mass convert into kilogram. 57.642 multiply 10 raised to power minus 3 kg, and 49 centimeter power 3 convert into meter the power 3. 49 multiply 10 raised to power minus 2 whole power 3 in meter the cube. And when we solved it, 57.642 multiply 10 raised to power minus 3 over 49.0 multiply 10 raised to power minus 6. 57.642 divided by 49, we will get 1.176, and this subtract with this, this cut with this, and we will find 10 raised to power minus 3. When we take it in denominator to numerator, it change the sign of power. Kg per meter the cube. Now next topic is temperature. It is defined as the degree of hotness. It defined as degree of hotness or coldness. Many scales are used to measure the temperature, and 3 common scales are used. Degree C, that is represent to Celsius. K, that is represent to Kelvin. Degree F, that is represent to Fahrenheit. K is the SI unit of temperature, and degree Celsius C is equal to K minus 273.15. Kelvin is equal to degree Celsius plus 273.15. The lowest temperature permitted in nature is lowest temperature permitted in nature is minus 273.15 degrees Celsius or 0 K, and this temperature is also known as absolute zero. Or similarly, Celsius and Fahrenheit scales are related to degree Celsius is equal to 5 by 9 in bracket degree Fahrenheit minus 32, or degree Fahrenheit is equal to 9 by 5 degree Celsius plus 32. Now next, you should keep in mind some point. The temperature below 0 degree Celsius having negative values which possible in Celsius scale, but in Kelvin scale negative temperature is not possible. Now next, you can see here this is a Kelvin, Celsius, Fahrenheit. These are the thermometers which are using different temperature scales. Now next, convert the following temperature into degree Fahrenheit. First is a 25 degree Celsius room temperature, and we will take here formula of degree Fahrenheit 9 by 5 degree Celsius plus 32. 9 by 5 multiply 25 degree Celsius and 5 cut with this. 5 ones the 5, 5 fives the 25, 9 fives the 45 plus 32, that will be 77 degree Fahrenheit. And in second, we have given degree Celsius 35. 5 ones the 5, 5 7 the 35, 9 6 7 the 63, 63 plus 32, that will be equal to 95 degree Fahrenheit. Now next, next question, at what temperature will both Celsius and Fahrenheit scales read the same value? Suppose both read the same value as x. Degree Celsius is equal to 5 by 9 degree Fahrenheit minus 32. And degree Celsius represent to x 5 by 9, and Fahrenheit is also represent to x minus 32, and 9 multiplied by x 9x, 5 multiplied by x 5 multiply 32, and 160. 9x minus 5x is equal to 116. 4x is equal to 160, and x is equal to minus 40, and this is the answer of x. And in second example, a measured temperature on the Fahrenheit scale is 200 degree, and what will be the this reading on Celsius scale? Again we have to write here formula. Fahrenheit is equal to 9 by 5 degree Celsius plus 32, and Fahrenheit is given 200, 9 9 by 5, and degree Celsius we have to find out plus 32. What will we do? You can do 200 minus 32 is equal to 9 by 5 degree Celsius, 168 equal to 9 by 5 degree Celsius, and 168 multiplied by 5 divided by 9 equal to degree Celsius, and 9, when we solve this, 8 5s are 40, 16 5s are 80 plus 4, 840 divided by 9, and you will find out result, that is approximate 93.3 degree Celsius. Now next topic is related to uncertainty in measurement. Uncertainty in measurement, in this we can say, in the study of chemistry there are several ways by which we can do numbers handled conveniently and data is presented realistically with the certainty to the possible extent, and these ways are scientific notations, significant figures, dimensional analysis. And scientific scientific notation can be represented capital N multiply 10 raised to power small n, and small n is a exponent, positive or negative value. Capital N is a number, that is a digit term. It will be 1.002 9 point, it will be 1.002 9.999, and this is a exponent. It will be positive or negative. So its value will be 9.43876 multiply 10 raised to power 2. If we have given 943.87, and in scientific way we can write like this. In the uncertainty in measurement there are two methods. First, calculations involving multiplication and division. Second method, calculation involving addition and subtraction. Now first I am doing multiplication. For example, we have given n1 multiply 10 raised to power n multiply n2 multiply 10 raised to power n, n1 plus n2, then multiply 10 raised to power n. Multiply, and in division case n1 multiply 10 raised to power n divide n2 multiply 10 raised to power n. In this case n1 divided by n2 and multiply 10 raised to power n 1 minus n2. Here also n1 plus n2. You can take here n1 n2. Now next is addition. In case addition, n1 multiply 10 raised to power n1 plus n2 multiply 10 raised to power 2. In this case n1 plus n2 multiply 10 raised to power n. Here it will be different values, or you can say you can take n1, you can take or you cannot take, it's your choice. Now subtraction. N1 multiply 10 raised to power n minus n2 multiply 10 raised to power n. N1 minus n2 multiply 10 raised to power n. These are the method for solving multiplication and division, addition and subtraction in scientific notations. We can take one example. We have given we have to convert these values in scientific notation like 0.00968. You can see here 1 2 3 4 5 6. When we write like this, 1 1 2 3 4 5 6 and 968 multiply, take a 1 point and it will be 100. Multiply 100 over this 9.68 multiply 10 raised to power 2 minus 6. 9.68 multiply 10 raised to power minus 4 is the answer. Now next one more example. 157,428. 1 2 3 4 5. 1.7428 multiply 10 raised to power 5. Next question, 90,000. In this case 9 multiply 10 raised to power 4. 5.7 multiply 10 raised to power 6. Multiply 4.2 multiply 10 raised to power minus 2. 5.7 multiply 4.2 in one bracket and 10 raised to power 6 plus minus 2 and when we multiply 5.7 with 4.2 you will get 23.94 and 10 raised to power 4, and in standard form this point shift with here, so 2.394 and 10 raised to power 5. 1 plus. Now next question is related to division. 6.8 multiply 10 raised to power minus 9 divide 1.4 multiply 10 raised to power minus 6. 6.8 multiply 10 raised to power minus 9. 1.4 divided and power will be minus and it will be 4.857 multiply 10 raised to power minus 3. Now next question, 4.56 multiply 10 raised to power 3 plus 2.62 multiply 10 raised to power 2 4.56 plus 2.62 and multiply 10 raised to power 3. We will take we will take 110 from this, so that this will be same. And 45.6, and now answer will be 48.22 multiply 10 raised to power 2 and 4.822 multiply 10 raised to power 3. Now next 9.87 multiply 10 raised to power minus 3 minus 2.26 multiply 10 raised to power minus 4. 9.87 multiply 10 raised to power minus 3 minus 2.26 divided by 10 multiply 10 raised to power minus 3. Now 9.87 multiply 10 raised to power minus 3 minus 0.226 multiply 10 raised to power minus 3. 9.87 minus 0.226 and 10 raised to power minus 3 is common, and when we solve it we will find out 9.644 and multiply 10 raised to power minus 3, and this is a standard form. Now next topic, accuracy and precision. Accuracy and precision means accuracy is the agreement of a particular value to the true value of result, or it's a measure of difference between experimental value or mean value of a set of measurements and true value. We can say that accuracy is equal to mean value minus true value. Smaller difference between mean value and true value, larger is accuracy. Smaller difference means larger accuracy. And accuracy also expresses the correctness of the measurement. Next is precision. Precision is equal to individual value minus arithmetic mean value. Precision refers to the closeness of various measurements for the same quantity, or it is expressed as the difference between measured value or individual value and arithmetic mean value for a series of measurements. And smaller difference between individual value or repeated measurements, greater is the precision. For example, we have given this is the example. I will take a blank page. Two students perform same experiment separately and each one of recorded two readings of mass which are given below. And correct reading of mass is correct reading of mass is 4.0 gram. On the basis of given data, what would be your infer about the accuracy and precision readings of students A and B? We have given students reading students readings first and second. A student B. A's first reading is 4.01, second reading 3.99. B's first reading is 4.05, second reading is 3.95. And we will find average reading. Average readings of students A is equal to 4.01 plus 3.99 divided by 2, that is 4.00. Average reading of students B 4.05 plus 3.95 and divide by 2, that is equal to 4.00. And correct reading is 4.0. For both students, average value is same as the correct and the readings of both are accurate. So readings of student A are close to each other, differ only by 0.02 and also close to the correct reading. Readings of A are precise also, but readings of B are not close to each other, differ by 0.1 and hence are not precise. And in next topic, significant figures, I have already discussed in physics class. You can watch that video. And here I will only discuss its some rules, just remembering. First rule is all non-zero digits are significant. Zeros between two non-zero digits are significant. Trailing zeros are significant only if digit contain decimal point. And leading zeros are not significant because their purpose is simply to place decimal point. And defined values or counting numbers have infinite number of significant figures, as these are exact numbers and they can be represented by writing infinite number of zeros after placing a decimal. And in numbers written in scientific notation, all digits are significant. Now I am going to discuss with you one question related to round off up to 3 significant figures. Round off up to 3 significant figures. For example, you have given 34.216 and the digit to be removed is less than 5. Therefore, preceding digit is not changed according to rule. If less than 5, no change in preceding digit. And up to 3 significant figures, You can see here 2. 2 is less than 5. You can see here 1 is less than 5. Just a minute. 34.2. You have to watch this number. 1 is less than 5, so that's why 34.2 is as it. 10.4107. And here you can see 10.4 approx. And next 0.04597. You can see 3 digits, 460, 0.0460 approximate. 2808, 2.808 multiplied 10 raised to power 3. And 2.8 unit digit 8 multiplied 10 raised to power 3. Now next topic is law of chemical combination. Next topic is laws of chemical combinations. Law of chemical combination. Elements which combine to make compounds in accordance to following 5 basic laws, that is known as law of chemical combination. First law is law of conservations of mass, and second law of definite proportions, and third law of multiple proportions, and fourth law of gaseous volumes by Gay-Lussac, and fifth Avogadro's law. First law of conservations of mass. This law was put forth by Lavoisier in 1789. According to this law, matter can neither be created nor be destroyed. What one form of matter can be converted into other, and this law is known as law of indestructibility of matter. And we can say other statement of this law is that in all physical and chemical changes, total mass of reactants is equal to that of product. Means sum of masses of reactants equal to sum of products. In this sum of masses of reactants is equal to sum of masses of products. Example, you can take example. If 6.3 g gram 6.3 g of NaHCO3 are added to 15.0 g of CH3COOH solution, the residue is found to weigh 18.0 gram. What is the mass of CO2 released in the reaction? First we have given NaHCO3. When we add CH3COOH, we will get H2O plus CH3COO Na plus CO2 and H2, and this is residue. Means sum of masses of reactant, sum of masses of reactant means 6.3 plus 15.0, that is equal to 21.3 gram, and sum of masses of products, that is equal to X plus residue is equal to 18, and sum of masses of products is equal to 21.3 is equal to X plus 18, and we will find X is equal to 3.3 gram CO2 which is released. Now second law of chemical combination is law of definite proportions. Law of definite proportion which was given by French chemist Joseph Proust in 1799. And according to this law, a given compound always contains exactly same proportion of elements by weight. And it is sometimes also referred to as law of definite composition. Example, pure water obtained from any source, well, river, lake, sea, etc., or any other countries, It will be made up of only hydrogen and oxygen elements, and which combine together in the same fixed ratio of 1:8 by mass. Now take one question. For example, we have given copper oxide was prepared by the following methods. In first point, we have given 1.7 gram of the metal was dissolved in nitric acid and igniting the residual copper nitrate yielded 2.19 gram of copper oxide. And we have to find out copper oxide, that is represented by Cu, equal to, we have given 1.75 gram of metal. 1.75 divided by 2.19 copper oxides copper nitrate, and we will get 79 point when we multiply by 100, and we get 79.91 gram. This is a percentage of Cu, that is 79.91. Okay, now you can see here second experiment. 1.3 gram of copper oxide contained 1.14 gram of copper. 100 gram of copper oxide contained, and it will be solved by this method. You can see here Cu is equal to 1.14 divided by 1.43 and multiply by 100, and you can get 79.72. In third experiment, 1.83 gram of copper oxide and which contained 1.4 gram of copper, and Cu 1.46 over 1.83, that is 79.78. And the percentage of copper in copper oxide derived from all three experiment is nearly same, and so above given this law of definite composition. Now next is a law of multiple proportion. This law was proposed by Dalton in 1803, and it states that if two elements can combine to make more than one compound, the masses of one element that combine with a fixed mass of other element are in the ratio of small whole numbers. So two compounds, water and hydrogen, You can see here hydrogen plus oxygen, that is equal to water. 2 hydrogen part and oxygen 16. When we plus, that will be equal to 18 G. And hydrogen G, uh, 2G plus oxygen 32, then hydrogen peroxide will be 34G. So masses of oxygen 16 gram and 32 gram that combine with a fixed mass of hydrogen, that is 2 gram, where a simple ratio 16 is to 32, that is 1 is to 2. And you can take one question. You can take here one example. We have given 3 oxides of nitrogen, 63.6%, 63.6%, 46.7%, 30.4%. These are the 3 oxides of nitrogen. And when we subtract 100 minus 63.6%, we will get 36.4 of O in first step. And in second step you will get 36.4 divided by 63.6 of O. It will be equal to 0.57 gram of O. And like this you will find out other 2 oxides of nitrogen. And next, in second case, first subtract 100 minus 46.7, that will be equal to 53.3 G of O. And then 53.3 divided by 46.7, that will be equal to 1.14 gram of O. And 100 minus 30.4, that will be equal to 69.6 gram of O oxide. And 69